All right, so we are in your yellow packet and we are on page 13. So to start on page 13, we have to review some of our angle vocabulary. So angles whose measure add up to 90 degrees are called complementary angles. Vertical angles, or sometimes I like to call them bow tie angles, because they look like this, and if you connect the two lines, kind of make a bow tie. They're equal, so they are called congruent angles. Angles whose measure adds up to 180 are called supplementary angles. An angle whose measure is less than 90 is called an acute angle. So parallel lines are the types of lines we are going to be dealing with today. They are lines that never meet, like a set of perfectly straight, infinite train tracks. Perpendicular lines we're not going to be dealing with today, but just to remind you, they are lines that intersect at a 90-degree angle. And so the symbol that we'll see for parallel lines are two lines straight up and down. The symbol for perpendicular is two lines that make a 90-degree angle. Mathematicians are not very creative, so when they come up with the symbols, they try to make them as straightforward as possible. Transversal, though, kind of an exception to the rule. That's kind of a creative name, and what it is a line that intersects two or more lines. So what we're going to be dealing with today are transversals with parallel lines. So a line crossing parallel lines, because their angles are going to have some special properties. So in this diagram, which of the lines are the ones that are parallel? The ones that never seem to cross are A and B. The transversal is C because it cuts across both A and B. And you can kind of already see there's some similarities or congruence between 1, 2, 3, and 4, and 5, 6, 7, and 8. They kind of look to be the same exact thing. So we're going to be identifying congruent, which means equal, angles formed by a transversal. So here we know that angle 1 is 150 degrees. So which other angle in this diagram looks like it's also 150 degrees? Well, angle 1 and angle 3 are our bow tie angles. A little bit of a sideways bow tie, but they're a bow tie nonetheless, which means they're vertical. So angle 1 and angle 3 both have to be 150 degrees. To find angle 2 and also angle 4, because they're also bow tie angles, we're going to notice that the blue and the purple angles are supplementary because they form a straight line with each other. So what adds with 150 to make 180? 30 degrees. So if angle 2 is 30 degrees, angle 4 is also 30 degrees. But what I'm noticing is if I were to pick up line A and place it right on top of line B, I'm noticing that angles 1, 2, 3, and 4 would line up perfectly with angles 5, 6, 7, and 8. So what that means is angle 6 and angle 8 are also bow tie angles of 30 degrees, vertical angles. And angles 5 and 7 are another set of bow tie angles, matching with the purple ones here, 1 and 3. So they must also be 150 degrees as well. So in a diagram with two parallel lines, all of the angles share the same measure. So they're either going to be, in this case, 150, or they're going to be 30 degrees. You only really see two different measures in these diagrams. So let's say angle 1 was 36 degrees. The bow tie angle with angle 1 is angle 4, the vertical angle. So angle 4 also needs to be 36 degrees. Angle 1 is in the top left corner. So is angle 5. So angle 5 is also going to be 36 degrees. And angle 4 Angle 8 are in the bottom right corner of their lines, so that's also going to be 36 degrees. To find the remaining angles, I notice that they make a straight line with all of my purple angles. So that means they're supplementary. So all I need to do is subtract 36 from 180, which is 144, to find that angle 2 is 144. Angle 3 is a vertical angle, so it's also 144. Angle 6 is in the matching corner of angle 2, so it's 144. Angle 7 matches with angle 3 to be also 144 degrees. So we either have a blue angle or a purple angle, and so our angles are either congruent to one another or they're supplementary to one another. Those are the two relationships with our parallel lines. So we're going to use some vocabulary to identify all of the 8 angles that are formed by a transversal. So to do that, I'm going to kind of make a box with my 2 parallel lines. Anything on the inside of the box is called an interior angle. Anything on the outside of the box is called an exterior angle. So we have the outside of the box. So we have several exterior angles in this diagram. The angles outside the box are 1 and 2. So angles 1 and angles 2. Angle 7 and angle 8. Those are exterior angles because they lie outside of the box. We also have interior angles, angles inside of the box. So the interior angles are 3, 4, 5, and 6. So angles 3 and 4, angles 5 and 6. It's helpful to know that because that helps us with these words: alternate interior, alternate exterior, same side interior, and we're also going to add on same side exterior. So mathematicians are not very creative. I've said that before. So when they named alternate interior angles, they were talking about angles inside of the parallel lines on opposite sides of the transversal. So 3 and 6 would be alternate interior. 4 and 5 are also on opposite sides, so they're also alternate interior angles. For alternate exterior angles, it's the same idea. They need to be on opposite sides, but on the outside of the parallel lines. So 1 and 8 are on opposite sides. 2 and 7 are on opposite sides. What I notice about 1 and 8, 2 and 7, 3 and 6, 4 and 5, these are all congruent angles. So alternate interior and alternate exterior are always congruent to each other. Now let's look at the same side interior angles. So same side means they're on the same side of the transversal. So 4 and 6 are on the same side. That's one pair. 3 and 5 are also on the same side. These angles, you can tell by looking, 4 and 6, they're not congruent. They're actually supplementary. They add up to 180. Same with the exterior ones. So a pair of exterior same side angles would be 2 and 8. So angle 2 and angle 8. And angles 1 and angle 7. Also same side exterior angles because they're on the same side of the transversal, but on the outside. What we'll notice is these are also supplementary. So these angles are supplementary angles. They add up to 180. And then the last type is corresponding. The way I like to remember corresponding, they are the matching corners. Corresponding kind of sounds like corners. So if I look at angle 1 is top left. Angle 5 is also top left, but on the bottom parallel line. So that's one set of corresponding angles. Another set of corresponding 2 and 6 because they're on the top right of the angle of the parallel lines. 3 and 7 are corresponding because they're in the bottom left corner. And 4 and 8 are also corresponding because they're in the bottom right corner. So those are our matching corner angles, corresponding angles. These angles are also congruent, meaning they're equal. So this just states what we just said. Corresponding are congruent, alternate interior, alternate exterior are congruent. And then I just want to write that same side interior and same side exterior are supplementary. So those are the only ones that add to 180. Same side. They have to be on the same side of the parallel line to add up to 80. All right, so here we know angle, the top angle is 124. So they want us to find angle 4. Angle 4 is in the top corner, which means it's corresponding to angle 124. So it has to be congruent. Angle 7, so angle 7 is a bow tie angle, a vertical angle with angle 4. So that means it's also 124. It has to be congruent. And then the last angle, angle 1, is supplementary. It makes a straight line with 124. So to find angle 1, we have to do 180 minus 124, which is going to be 156 degrees. Oh, not 156, just 56 degrees. Perfect. So that's how you use angle relationships in parallel lines to find the missing